Hello everyone. In this small recording, I will be covering Feistal structure. One of the question is based on this Feistal structure, which is of course a bonus question. Here in this particular question that I have given in the final exam review, if you will see that you have a block cipher which contains 8 bit of blocks, and the scrambling function over here is, and it contains 2 rounds, one where each round has a function f of I, which is a combination of x and k. X is the data and key is the key, and which is equal to I times k to the power of x modulus 15 for both of these round, where key k is a member of Z15, which means that we have to apply mod of 15. Here key value is 7 and the cipher text which is given is 00110011. So if a question like this is given to us, first of all, we have to compute what would be this f of I. So f of I is a combination of some bits and k. So if you recall in a Feistal structure, what happens is that there is a plain text where you divide the plain text into 2 parts, left and right. The the first few bits which are considered as left hand bytes are combined with a function of the key value which is given along with the right hand side few bits, and that function, whatever the output of that function, is an input which is given to round number 1, where left bits are taken into consideration, and a function of key and r, whatever is the output would be the right bit, then followed by whatever is the previous right bit becomes the left hand side, and then same combination happens once again. Function is taken where function is a combination of key k2 and r. Whatever is the output is fed into this particular round where left hand side and this function output would be XORed, and whatever is the output becomes the right hand side, and the previous right hand side becomes the left hand side. This happens in typical Feistal structure. So here in this question, you are given a cipher text and you have to compute the plain text. So you are given the values which are over here, which is round 1 and round 2. You are given these left hand side and right hand side bits. What you have to compute is you have to compute the plain text. So you will start from the bottom and then you have to go up. So how would we do that? First of all, we have to know what is the function. Here in this function, what exactly is done is that it takes x and k, and then it is I times k x modulus 15. That is what the function is given to us. So f of 1, which is like these two functions. So for round number 1, what we are given is that there is a function x along with this key, which in this case is 7. So if we will take the binary of this 7, this is 0, 1, 1, 1. So this would be 0, 1, 1, 1. This would be equivalent to whatever is the round. So here in this case, the round is 1 times k, where key k is 7, to the power of x, which we do not know right now, but we will compute, and that is mod 15. So if I say f of 1 would be x comma 7 is equals to 7 times 7 to the power of x mod 15. That happens in round number 1. For round 2, which is f of 2 would be x once again 7, and here in this case it is I to the power of I times k. Here since it is second round, so it would be 2 times the key, which is 7. Here it was I, this was for round 1 and this is for round 2. So round 2 it is 2 times 7 to the power of x mod 15, which in this case would be 14 to the power of x mod 15. So what we have to do the similar kind of operation in order to get the value of the plain text. So here round 1 function is 7x modulus 15, and round 2 function is 14 to the power of x mod 15. So let's start with the like how would we approach to this particular problem. So here the ciphertext which we are given is 00110011. So we will start with the ciphertext which is at this particular round. This is given. So our left bits are 0011 and our right bits are 0011. This is what the ciphertext is given to us. Next, what we have to do is we have to apply a function. So if you will see, this is this right hand side, we will follow, this left hand side, we will follow similar Feistal structure over here. This is the previous round right hand side. So we know that this would be our previous round right hand side, which in this case would be 0011. The same right hand side is applied to this function. So this is our function, which is f of key and right hand side. So key which is given is 7 and the right hand side is this. And what we computed was this particular function, which is for round number 2. Round number 2, the function was this. So 14 to the power of x mod 15. 0011. This is the binary equivalent of 3. So we know that this is for round number 2. We know that it is 2 times 7 to the power of x. X we just found is 00111. So we will substitute this value, which is 14 to the power of x, which in this case is 3 mod 15. If you will calculate this value comes out to be 14, and the binary equivalent of this is 111110. This would be the output which would be fed over here. So this is 1110 and this is XORed. So if you will look at this, this is XORed with the with our left hand side. So if you see that whatever is the output of this becomes the left hand side, sorry, the right hand side, which in this case is 0011. So we know that the output is 0011, the input is 1110. What would be the combination that would lead to these bits when it is an XOR operation? So 0 times what? 0 XOR what would give us 1? 0 XOR 1 would give us 1. Similarly, 1 XOR 0 will give us 1. 1 XOR 1 will give us 0. 1 XOR 1 will give us 0. So we now know that this value is 1101. So this becomes our left hand side. So this is our left hand side 1101 and this is our right hand side which is 0011. Now we have just solved round number 2. Now we have to solve round number 1. In round number 1, once again, similar kind of operation will happen. So if I'll minimize this, if you will see here in this case, the left hand side now becomes a right hand side. So similar kind of operation. Here also we did the same kind of operation. If you recall, the left hand side becomes our right hand side. So similarly, the left hand side now becomes our right hand side. So in this case, we know that our output, the right hand side is 1101. Here once again, we have to apply function f of f1, key and r. Here in this case, we computed that for round number 1, this is our function, which is 7 to the power of x mod 15. So what we have to calculate, once again, we have to know what is the x value. And if you see that in the Feistal structure, the left hand side becomes the right hand side, which is 1101. So 1101, that is equivalent to 1101. The equivalent is 13. So this value would be 7 to the power of 13 modulus 15. In the write-up, when I had written 13 to the power of 7, which was wrong. It is 7 to the power of 13 modulus 15. So if we will solve this, we can apply the multiply and square operation in order to compute this value. So the binary equivalent of 13 is 1101. So I'll just put this as 1101. Whenever it is 1, it is z square times a mod of n value, which in this case would be 1 square times 7, which is a mod 13, which will give us the value as 7. Next time, once again, it would be 7 square times 7 mod of 13. If you will solve this value, sorry, mod of 15, this value would give us 13. Once again, 13 square, this is 0, so it would be just 13 square mod of 15. If you will do this, this will give us the value 4. And in the last case, it would be 4 square, which is z square times a is 7 mod 15, which would give me the value as 7. So the 7 would be the output in this case. So here is 7. So the binary equivalent of 7 is 0, 1, 1, 1. This would be given as the input to our XOR operation. So XOR operation is done between whatever is the output of this, which came as 0, 1, 1, 1. So 0, 1, 1, 1. And if we know that the previous round, right hand side becomes this as the input. So here in this case, I'll just use a different color. And if you see here, now this is the output. So we know the output, which is coming as 0, 0, 1, 1. And we know the one of the input is 0, 1, 1, 1. So what would be, what we would use in order to get this output is 1 times 0 will give me the output as 1. 1 times, 1 XOR 0 would give me 1. 1 XOR 1 would give me 0. 0 XOR 0 would give me 0. So our output, so our left hand side becomes 0, 1, 0, 0. So finally, our plain text is 0, 1, 0, 0, 1, 1, 0, 1. So we started with the plain cipher text. We will go in the bottom to the up direction, and we would be just following the Feistal cipher structure, which is dividing left hand side, right hand side. Once we have divided left hand side and right hand side, we will take the right hand side. The left hand side becomes the previous round right hand side, and the right hand side is the XOR operation between the left hand side and the function would be given to you. So this is how you would be solving in terms of Feistal cipher structure. I think try this once again from by scratch, if you have followed up this particular video. And similar question I would be giving you, but not as the main question, but this would be a bonus question. Let me know if you have any other questions. Thank you, everyone.